The first part of the prompt on page 193 of your textbook is to write the equation of the lines that would go through the points shown on the graph. So on page 93, you'll see points, and then you use a ruler or a straight edge to draw a line that goes through those points, and then you write the equation of that line either in slope-intercept form or point-slope form. You can choose either this form or this form. No matter which one you choose, if you put that equation into Desmos, you should get a line that looks like this when you graph it. The second part of this prompt is to verify that no matter which 2 points you choose on this line, any 2 points anywhere on the line, that the slope is the same, no matter which 2 points you choose. So there are different ways that you can do this assignment. The first thing that I would recommend is calculate or determine what the slope is. And also, I like to use slope-intercept form quite a bit, so I would also look and see what my y-intercept is. So that's one method. Let's do this one first, using slope-intercept form. So if you're choosing slope-intercept form, what you're going to do is you're going to determine what is your y-intercept, and you're also going to determine what is your slope. Because once you have those 2 things, your y-intercept and your slope, it's super convenient for writing your equation in slope-intercept form. So I'm going to look for my y-intercept first because I can see it just by looking at the graph. So the y-intercept is where does your line cross the y-axis, and that's this vertical axis that's labeled with a y. So where does your line cross this axis? And I see that it's right here. This point right here is where our line hits the y-axis. And I see that this is going by 2s. So from 12, 10, 8, 6, 4, 2, 0, -2, -4. So this is going to be -6 because I just counted down by 2s. So my y-intercept is -6 because the line crosses the y-axis at -6. All right, so we've got half of our equation already written because we know the y-intercept. So now let's look at the slope. So for the slope, what you should remember is that slope is rise over run. And another way of thinking about that that's a little bit more professional is it's the change in y over the change in x. And this symbol here that's looks like a triangle is the letter delta, the Greek letter delta. So delta y over delta x, and delta just means change. The change in y over the change in x. So first, choose any 2 points. I'm going to choose this point and this point, just because they're the first 2 that caught my eye. Okay? So now what I'm going to do is I want the change in y first. That's the vertical change or the rise. So I need to know how far is it from the level of this point to the level of this point. So I just want to know how far is this. And I see that it's going from -4 to -2, which I know is 2 jumps, right? From -4 to -2, if you subtracted, you'd get 2. So I know that the change in vertical distance is 2. And now I need to know what is the horizontal difference or the change in x. So now for the horizontal distance, I'm going to go from this point, where this point is, over to where the next point is. So how far is it from here to here? And I see that on these, on the x-axis, it's going up by 1/2 each time. Each line represents 1/2. So this is 1, 2, 3, 4, 5. So from this distance right here is just the distance from 1 to 2. And 2 minus 1 is just 1. So I know that my slope is 2 over 1, which is just 2, if you simplify it. So my slope is 2. Now, if you prefer the mathematical way of calculating slope instead of counting on the graph, another way you can think about rise over run is to subtract. So some people like this better, so I'll show you how you can do it. So what you can do is you can think about for the change in y, your one point is at -4, and one point is up here at -2. Okay, and then you're subtracting, because when you're looking for the difference between two numbers, that's subtraction. So we're taking -4 minus -2. And you'll also see that written like this, -4 minus -2. Then remember what you know, when you have minus a negative, that's the same as plus. So you have -4 plus 2, which is -2. And I know it's a negative number, but bear with me. It'll all work out in the end. Okay, so you have -2. And now we're going to do the run distance. Okay, so just like we did before, we started with this point before, so we're going to start with this point again. But this time we're looking at the x's, right, instead of the y's. So we have 1 minus where this point is, which is at 2. And 1 minus 2 is -1. And then when you simplify, if you did this on a calculator or in your head, if you did -2 divided by -1, that would come out to 2. So you can see we got exactly the same answer, whether we looked at the graph or whether we used math to do the calculation. So, okay, so that's kind of a segue. I'll get rid of that work for a second because we now know our slope and our y-intercept, and we're ready to write our equation. So now that we know our y-intercept and our slope, we can put our equation in slope-intercept form, which is this form: y equals mx plus b. And all we're going to do is substitute in our y-intercept where the b is, and substitute in our slope where the m is. So it's y equals m, which is our slope is 2, and then write down the x, and then our y-intercept is -6, so we have plus -6, which is the same as -6. So we've got our equation in slope-intercept form right here. Now, if you wanted to write the equation in point-slope form, that's this form. So we'll have y minus y1, y sub 1 I should say, equals the slope times x minus x sub 1. And what you do for this one is we already know the slope from the calculation we did before. So we know we're still going to have a 2 here. Okay? So let's just write down the parts you're going to keep. You're going to keep the y minus. You're going to keep the equals. We're going to put a 2 in for the slope. And then we're going to keep the x. And we're going to keep the minus. And then we're going to fill in the x sub 1 and the y sub 1. Okay? So what you do is you choose any point on this line. So just to keep things simple, or simpler I should say, I'm going to choose a point that has positive values. So I could use these points down here, but they're going to give me some negative numbers. I could use this point, but it's going to line up with a 0, right? Which is all fine. But just for the purposes of keeping it simple, I'm going to use one of these points because they're in the positive numbers. They're in the positive x's and the positive y's. So I'm going to use this point right here just for kicks, okay? So this point is 4, 2, because it's the y is 2 right here and the x is 4. So this point right here that I've circled is point 4, 2, because this is the x coordinate and this is the y coordinate. So 4 is our x and 2 is our y. And then, since these are both positive numbers, I just plug them in. The y is 2. I got that from right here. And the x is 4. I got that from right here. Okay. If you chose this point, these numbers would change. It would be the x of 5 and the y of 4, right? So this would be an equally correct answer. All right. Intrigues you that you can have two different forms of the equation for the same line? You can actually show using algebra that this equation and this equation, if you did some algebra on them, did some distribution and then isolated y, they would both come out to this same equation that you wrote over here. So if you're interested, do some algebra on this equation or on this equation to get y isolated by itself, and you'll see that these are equivalent to each other and they also are the same as this. So if you're interested in exploring further, I recommend that you do that.